We are doing measuring and constructing segments today, and we're going to start off with another postulate. This postulate is called 1-2-1 and the ruler postulate. So what this says is the points on a line can be put into a one-to-one correspondent with real numbers. So basically you can have a line segment, and if you lined a ruler up with it, each point on that line can be lined up with a number on the ruler. That's what it really is saying. So here's my awesome ruler. Distance is between 2 points. It's the absolute value of the difference of the coordinates. So distance is never negative. We don't go -7 feet. We go 7 feet, whether it be left or right or up or down or whatever, we're going 7 feet. So it's going to be the distance. We're going to have to figure out what those distances are. Length is another word for distance. So those two words will be used interchangeable in your problems today. And I have line here, AB, and the segment between, or the line segment AB can be decided by taking A minus B and then the absolute value of that, or you could do B minus A and take the absolute value of that to find the length or the distance between the 2 points. So for example 1, we have to find the length from B to C. So B is -1 and C is +3. So what this up here tells us is that I can subtract these two and then take the absolute value of that. So I have the -1 from point B minus the 3 from point C. So if I do the -1 minus 3, because absolute value isn't just another grouping symbol like parentheses, so we have to do what's inside first. -1 minus 3 is -4, and then I have to take the absolute value of that. So that distance is 4. Now, of course, you could count. This is a smaller example. You could count, but when you have larger ones, that might be a little bit more difficult to do so. All right, and then for part B, we have to find the distance from A to B. So A is -4 and B is -1. So we have to minus, and then our B is -1. So we're going to have actually two negative signs inside there. So -4 minus a -1 is actually going to turn into -4 plus 1. And when I do -4 plus 1, I get -3. And then I have to take the absolute value of -3, which is 3. And again, just a quick reminder about absolute value. That is how far the number is from 0. So that number is going to be positive as well. All right, congruent segments are segments that have the same length. So I have a picture here where EF is equal to HG, and you can write that line segment EF is congruent, so this little sign here means congruent to segment HG. And then I have AB equals CD, so those longer two. And we can write AB, line segment AB is congruent to line segment CD. So this is how we would write that. In the picture, it's shown by tick marks. So you can see EF and HG each have 1 tick mark. So those are congruent. And then AB and CD have 2 tick marks. So those two are congruent. So you just match up how many tick marks each line has. All right, construction is a way of creating a figure that is more precise. We're going to use a compass or a straight edge to do so. So here you are going to construct a segment congruent to segment AB. So the way you do this is you draw a line, use a straight edge, draw a line, and put a point on it. And for this one, they labeled it C. Okay. Then you're going to open a compass and you're going to measure that point from A to B. So you're going to put one point of the compass on A, open the other side so that it is sitting on point B. And that is your distance your length of segment AB. And then you're going to take that without moving it and put one of the points on C to make the line where the other point would be. And that's what they did here. And they got point D. So then on this line, they had C and D that was going to be the same measurement as segment AB. Another postulate says the segment addition postulate. If B is between A and C, then AB plus BC equals AC. So if B is between A and C, which in this picture it is, then AB, so this distance right here, plus this distance right here is going to give you this entire distance. So if you add the two smaller pieces together, you're going to get the larger distance. That's what that postulate is saying. So example 3, use segment addition postulate. B is between A and C. AC is 14 and BC is 11.4. Find AB. So I would suggest one of two things. Number one, we can look at this and plug in our numbers where they go in that equation, or we could draw a picture. Now, we're lucky in this example because they are using A, B, and C, so that goes right along with that equation from the postulate. If they were using different letters, it would be really kind of difficult to match that up. So that's when a picture would be more helpful, I guess. So if B is between A and C, so let's make this A, B has to be in between, and C. A to C is 14, so this whole section is 14. And BC, from B to C, is 11.4. We need to find AB, so we need to find this. So we know the total and we know one piece, we're missing the other piece, so we're going to actually subtract here. We're going to take that 14 and we're going to minus 11.4. And we would get 2.6 if we subtracted that. Next, S is between R and T, and we need to find R to T. So it looks like if we were to add the two smaller pieces together, we would have 2x plus 7, and then we have to add 28 to that, and we should get a total of 4x. So the two smaller pieces added together should equal the whole entire thing. So now we have an equation where we can simplify. The 7 and the 28 can go together. So we have 2x plus 35 equals 4x. And then we have x's on both sides of the equal sign. So I want to get rid of the smaller one here. I want to get rid of that 2x. So I'm going to minus it from both sides. So I would have 35 equals 2x. And then I have to divide by 2. So half of 35 would be 17.5. So x is equal to 17.5. Now they wanted to know RT, the distance of R to T, and that is 4x. So then we're just going to simply multiply that 17.5 by 4, and we should get an answer of 70. Midpoint is the point that bisects or divides the segment into two congruent segments. So the midpoint of this last one would be S. If M is the midpoint of segment AB, then AM is equal to MB. So if AB is equal to 6, then AM equals 3, and so does MB. So it's the midpoint. It's exactly in the middle, so that's why we could divide it up into 3 and 3. That might not be the case for my picture up above. The midpoint has to be directly in the middle. All right, so example 4, the map shows the route for a race. You are 365 kilometers from drink station R, so that's shown in the picture, and 2 kilometers from drink station S, and that's also shown in the picture below. The first aid station is located at the midpoint of the 2 drink stations. How far are you from the first aid station? So we need to find how far are you from X to Y, basically is the length of the segment that we need to find. So the missing piece is right here, and we don't know what that is. So let's call it X. So 365 meters plus X is going to give me 2 kilometers. Now I can't use 2 kilometers because they're in different units. So 2 kilometers is really 2,000 meters. So I'm going to use 2,000 here. And then I am going to subtract 365 from both sides. So I would get X equals 1,635. So that entire distance is 1,635. Need half of that, so I'm going to divide that by 2 since y is our midpoint, so we only need up to point y, and half of 1,635 is 817.5. So from here to here is 817.5. So I need this distance, so now I get to add the 365 and the 817.5 together to get a total of 1,182.5 meters. So this map, you are 1,182.5 meters from the first aid station. Bisector is any ray, segment, or line that intersects a segment at its midpoint. So it's going to cross at its midpoint. So this picture here kind of depicts how you would do that. So if you have a line X, Y, or segment on a piece of paper and you fold the paper so that Y, you fold that line in half basically. So it's symmetrical, the 2 points meet up. And then unfold it, that fold is going to be the line that is intersecting at its midpoint, and then they named that point M. So from X to M is the same thing as M to Y because we folded that line exactly in half. So example 5 says using midpoints to find lengths, B is the midpoint of AC. From A to B is 5x, and from B to C is 3x plus 4. Find A, B, B, C, and AC. Using our picture here, if B is the midpoint, then we know both segments are the exact same. So I can set these two equations equal to each other and then solve for x. So I'm going to minus 3x from both sides. So I'm going to have 2x equals 4, and then I'd have to divide by 2. So x equals 2. So plugging that back in from A to B is 5x. So that would be 5 times 2. So that would be 10. So segment AB is 10. B to C is 3 times our x, which is 2 plus 4. So that would be 6 plus 4. That's also 10, which makes sense because B was our midpoint. So they both should be the same. And then from A to C, the entire length would be both of those added together. So that should give us a length of 20.